Order a,
This meeting is being recorded.
I'd like to call to order the July meeting of the Homebrew Robotics Club. We've got a special presentation here. We've got a 3D printing roundtable. Thank you. Thank you, Chris. Before we get started, let's go to robot news. Is there any robot news out there that anybody wants to talk about? I've got a couple of pieces. Let's share my screen here. This is not good, but the chess playing robot apparently broke a boy's finger in Moscow. They need to debug it further. Apparently, you need to wait a minute after you move your piece or something, and the boy still had his hand down there, so it broke his finger, but seems like he's okay. Comes to mind the Star Wars advice.
Great. Thank you.
Let the Wookiee win, right? Okay. Another piece that I dug up is looks like this guy lost $176 billion worth of Bitcoin in a hard drive that he threw away. And now he wants to scan the landfill, you know, where that hard drive supposedly is. And he's trying to use two of the Boston Dynamics robot dogs to do that. New York's not letting him go through the landfill, though they say it would be ecologically not good. I'll put links for both these stories in the chat. Any more robot news out there? Going once, going twice.
Is there any new news on Robo Games that's coming up next year?
Robo Games is coming back again, and it'll be in April. I don't have the exact dates, but I'll get them. And actually, I'm going to try to make it into town for that auspicious occasion.
Are we going to have a presence there at all, or a booth, or are we just
Well,
going to be
Robo
showing
Games-
up as
Robo-
individuals?
Robo Games is different than Maker Faire. In Maker Faire, you'd come as a group. Okay, Robo Games is more about the individuals. There isn't really a homebrew robotics booth, so to speak, but we are a presence there. So we generally group up at a particular place, but in general, the Robo Games, let's see when this thing is going to be. April 6th through the 9th. Mark your calendars. Robo Games, April 6th to the 9th in Pleasanton. And so get your robot running. Is Ralph Hips there by any chance? We're trying to do a Robotnik in that park in Sunnyvale with Robo Magellan. I think that's going to be in September. And so let's get some Robo Magellan robots going. Hey, Marco.
No, okay. I think September the 10th.
Okay. Well, let's try to get some Robo Magellan robots together, and anything that's at the Botnik should be at Robo Games also. So good times. What else?
Did you, I just posted the news story there. Did you guys talk about, I came a little late. Did you talk about the dead spider robots yet?
Why don't you tell us about those dead spiders, Scott?
All right, can you, yeah. So this story's been going around and it creeps me the heck out. And basically what this team did is they took dead spiders and the spiders move their legs basically with hydraulics. That's how they work. So they pump hydraulics into these dead spiders to use them as grippers to pick things up. And it is just like, it's the scariest, creepiest idea I've ever thought of. And I don't know if it has any practical use, but it creeps me out. And I was like, oh, I finally saw some robot news I can share.
Well, I was trying to go to the my Google Photos. Maybe I'll dig it up later, but in a challenge meeting, must have been 4 or 5 years ago. Somebody actually showed up with a cat that they'd reincarnated. It wasn't their
Oh
cat,
Lord,
but
that is
yeah,
that's
like a
that's,
cat
that's
skull with
terrible.
LED eyes and stuff.
Oh
It's
my
like,
gosh.
oh, okay.
Yeah, we robot people are, we're all weirdos. You know?
Some are weirder than others. Welcome to the uncanny valley.
You mentioned someone reviving a cat. Was it Schrodinger's cat?
That's funny. That's a good one.
It was in the box. We don't know.
Yeah, there you go. There you go. All right. What else today? What else in the robot news? Okay. Let's move on to club news here. Next month, our own Scott Monahan, did I get that right? It's going to be
That's
showing
right. Yep.
Robot, lovable, accessible, autonomous companion. So that's going to be our presentation next month. And then after that, we've got another challenge meeting where you are responsible for the presentation. So get your robots running. You are working on something, right? This is a robot building club. Robots are our medium of exchange. How do we say that? Robots are our medium of exchange. Good enough, anyways. And of course,
Currency.
yes, works in
Nuts and
progress are
bolts.
good for what do we call it? Works in progress are good for partial credit. There we go. Functioning robots are our stock in trade. Works in progress are good for partial credit. There we go. I'll get it together here. Okay. Any more club news out there? What I need help with. Has anybody got a what I need help with?
I have one thing right now for Robud. So this is a fun thing. So you guys put me in contact, I think, with the ChaiBots robot group, which is a few guys out here who've been doing their own Chicago robots thing for a long time. And I got to go out with them to a library in Chicago South Side where we showed off robots to kids. And one of the things we showed off was Robot, and kids loved it. And what they loved the most was sitting down and talking to it. And it was really amazing because there was another volunteer who I showed how to run Robot, and they were having a lot of fun doing it. So they were teleoperating Robot and making it say things based on what the kids said. And it was really magical to like see people enjoy it. And so I want to add a chat bot built into Robot. And I was looking at different frameworks, and at first I was looking at RASA, and I looked at like the Microsoft bot framework, but those are all so geared towards like customer service, like bots, almost like, the people, or the people you get on the telephone where it's like the robot on the telephone telling you to press 1 or press 3. And I really want to have something that's almost more along the lines of the old school, like if then, chat bots that have been around for a real long time. And I'm thinking I'm just going to code my own basically deterministic chat bot that has different options that'd be fun to talk to. But I don't know, does anybody here have experience with a framework that I'd be able to plug into Python that would just make a fun robot that you can talk to, but also where it feels like you're really talking to someone, but also take commands and be able to do things and pick. It's also going to be really important for like, robot says, "Hi, I'm Robot. What's your name?" And then you say, "I'm Camp," and he says, "Oh, hi Camp, how are you? I'll remember that next time." Those are the kind of things that I want to do.
Aren't the guys in the Southern California group, they're all have on some particular AI. I can't recall what the name of it is right now.
Oh, just one important thing for Robot that is a limitation is that I'm really trying to run everything locally and not have anything go out to the internet, because it videotapes people, it hears their voice, and so privacy is a big thing that I'm trying to maintain with the bot.
Yeah. I
Okay,
think that there's
you just I think answered my question here. I was going to suggest if you looked into Alexa, but you just said you don't want to work online, so that won't work. But I think Alexa.
Yeah, I've been I looked into Alexa and I looked into Mycroft, and Mycroft is like an open source project. It is really neat. It's an open source, very basic and open source Alexa. The problem is it still requires, it still takes your audio, sends it off to a remote server, and then figures out what it says, and then, you can talk back to it. And it's a self-imposed limitation, but, I personally have been thinking about getting rid of my Alexa because it's been advertising to me. And it's more intrusive than I'd like it to be. And especially for like this little robot, like it was interacting with kids that, I don't know, and I don't have permission from their parents to, film them or whatever. And I don't want it to be, taking their audio and sending it off to, some, third party, even if I trust, that they won't do anything with it. It just doesn't seem right privacy wise. Does that make sense? And it's also a challenge that I want to see if I can do it. But I appreciate that. I think I'm going to roll it my own.
Yeah, because there was an article in Make about like 2 years ago about like that, because you knew the two components, the voice to text, and there was a couple options on the voice to text, and then the output text to voice. And then for in between, you need the AMIL. We use that on the My Robot Lab for the InMove, the humanoids, the AMIL that converts I give an input, basically a chat box with a whole bunch of options there.
Right. And
Right.
so that's what I would be like. Do you, Dee, have like, are there Python libraries that you used for your MIL?
Yes. So, well, the AMIL is the kind of the spreadsheet, but when I did it in the InMove, then you could link the AMIL to like, it has this trigger phrase, and then you could do some movements associated with that. And so basically I went through the My Robot Lab documentation, or what there is of documentation, and kind of reverse engineered it for my own purposes. And the nice thing about My Robot Lab is it has like, let's say 50 or more AMIL files already generated, and then you just add your own customized. So you're not starting from a blank library, but you have a fairly big library to start with. So that's nice too. And multiple languages.
Awesome. Yeah, I will check that out. AMIL on My Robot Lab.
Yes.
Cool. Thanks. I'll take a look at that before I try to reinvent the wheel myself. So thank you.
Yeah, and if I find that Make magazine that had a whole bunch of offline text to it's both ways.
I do have text to speech and speech to text solved.
Okay.
I got that. It's just the logic of making it be able to have an autonomous conversation rather than my controlling it 100% like a puppet.
Oh, yes. Okay, yeah, AMIL.
Awesome. Thank you very much, Dee.
What else we got for what I need help with? We had a good time at the cross discussion group last night, and Alan Fetterman and I were going around the horn trying to get the Raspicam working with 64-bit Ubuntu. But anyways, the long story short, and you may have seen it on the email list, is I just used a regular webcam from Logitech, and I got it working with the video for Linux, and it doesn't seem to be an issue. So
once you plugged in the USB cam, which I said the first thing, and we went all around it anyway. On the last thing, I just looked up a article that was published this year. It's in researchgate.net, and it's ROS-based control of robot using voice recognition. So you might want to look at that.
You're talking about robot now?
Yeah, I was talking about the last, what I need help with it.
Yes, thank you. Can you repeat that again?
Yeah, researchgate.net,
Mm-hmm.
ROS-based control of robot using speech.
Okay. Thank you.
Hey, Al, you might want to take a look at the camera for the group there.
I don't know where the camera is. Camera's on the laptop. We're gonna switch to the phone when people start speaking. Okay. Hello? No, you don't see me. Yeah. Did everybody get a chance to sign in, by the way? I haven't.
Hey, Al, did you look at that camera? What else do I need help with? Any more what I need help with? Okay, now it's time for show and tell. Who has a show and tell?
There are several show and tells here at the Maker Nexus.
Why don't we start off at Maker Nexus and do the show and tell, and why don't you host that, Wayne?
I will do so. So our very own Katrina is going to demonstrate her robot. And you got to see how pretty her laptop cover is. So the camera's right over here. Okay, so okay.
Right here. Okay.
Okay, so this is actually so this is actually Magni, but I call it Christina. And I programmed it to turn in circles and wait. Yeah. So it turns into circles and it plays music.
Can you turn the camera so that we can see it?
Yeah, can you switch it, Chris? Can you switch it to my iPhone because the camera's right on her? Is Chris still on? I can't switch it.
Yeah, but your camera's not transmitting video.
It's going.
Very cool. Christina, why are you going in circles?
It takes a bit of time.
Yeah.
Wow, that's great.
Chris, can you put the focus on my iPhone, please? Very good. Okay. Now, could you tell me what the name of the robot is again? Christina? Okay. The robot's name is Christina. Very good. Very good.
Okay, so who's next? Who has another robot to show? Mark, come on up.
You ask Camp to put the video onto my iPhone.
Camp, if you can hear me, can you please use Dan Tukler's iPhone as this? Yeah, okay, it's going.
All right, so yep. So this is a similar sensor that showed up twice at the last meeting. I just thought it'd be interesting to have a little graphical display. So it's using an OLED display, and what it does is this is the VL. This is the 8x8 time of flight sensor that's very common these days as a really cool thing right off the shelf. So it's a VL53L5CX, but basically 8x8 time of flight. So what I need as a volunteer is we're going to put the phone up to it, and you'll see that it's seeing the phone. The brighter the dots, that means the closer it is. And then you back away and you get this image of the littler dots because the things are farther away. So it's a nice little graphical way to see the sensor work. And as Rohan pointed out earlier, he said, I wish I had that during my debugging. So anyway, I've got an Arduino sketch for this. It's based on the Adafruit driver. It's fairly straightforward. The only big problem is you need not just a nano, you need a little bit more powerful Arduino because of the memory space and also because of the way the library requires a particular timer. But this is my this board on top is a board that you've seen many times in demos in the past here. That's a ESP32 based dev board that I use for all kinds of things. So I'm just using it here for I2C, and it drives the display as well as the VL53L5 device. Anyway, that's it. I'll have it over there. People can put their hand in front of it and so on later.
Thank you very much, Mark. Okay. Let's go for the next robot. Do we have another robot here? I think there was one more. Who was it? Are we only two robots tonight? There's a conveyor bot back there. I know we're going to be giving a presentation on that. Okay, hang on. The presenter is off talking with somebody. This is going to be fun. Okay, can you come all the way up here, David? And
Sure, no problem. So this is conveyor bot over here. It's a really simple system. Basically, what it does is it looks at the S tag markers. Maybe Rohan, could you just press the start button on there? And what it does is it sees the S tag markers on the ground, and when it sees an S tag marker, it turns in the direction of the S tag marker. So it's a very, very simple system. That's conveyor bot for you. Okay, could you please stop it? Hit the pause button. So yeah, it's obviously built on the Magni platform, and yeah, that's a conveyor bot.
And you just earned a level 2 Floorbot challenge.
Put in patterns that make different decisions at different points.
Yes, you can. So if I can, so if I can get these things. So the basic configuration is you have go markers green, stop markers red. You have go markers green, stop markers red, but then you can also put in turn markers. I don't know if the microphone is going to extend.
I'll switch to this mic.
Good old fashioned iPhone.
Okay, so what you can then do.
Can you guys hear him?
What you can then do is you can then program in little routes into the robot. So for example, here I've got this route, Easy Street, which just is these turn markers 3, 4, 5, 0, which are the markers that are laid out here. But you can program any route you like. So you can just put down green go markers, and whenever you have a turn, you can put a turn marker in. And essentially by selectively ignoring markers, you can create branching routes of varying degrees of complexity, which you just select from the pull-down menu. Now, right now, we only have the Easy Street route programmed in, but you can have an unlimited number of routes, just by putting in the appropriate turn markers for the appropriate thing. Okay.
How is it safe in a human environment?
You've got, normally you'd have a LiDAR attached. This robot doesn't have a LiDAR attached, but the LiDAR acts as a safety sensor. So if you stand in front of the robot, it'll stop. So yeah. Any other questions from Mark and Alan?
What happens if it misses the? Hello?
I'm Rohan. Well, I mean, Magni, as you know, it's 100 kilo payload. I mean, I can stand on with this one, but we normally said go about 50 kilo payload. Yes.
What was your motivation for making that design?
So what we wanted was a conveyance robot that was easy to use. Typically with conveyance robots, you have like a LiDAR-based AMR-like thing. And those are difficult to set up. You have to have somebody come in and map your space and set up all the routes and so on. Then you have to figure out how to make the robots work together and so on. So what we wanted, or you could do a line follower. Line followers aren't that easy either because you have to paint lines everywhere. The lines get mucked up. And it's not a very flexible system, a line following robot. You can only follow the line. And there's limited ability to turn. So we wanted something that was more flexible, but easy to program. And so we started with the idea of, well, can we just have green is go and red is stop, and have routes defined by the green is go and red is stop. We then sort of thought, well, wouldn't it be nice to also have the ability to add in turn so you could go into different directions? And that's why we put in these turn markers. So that's the basic setup. Yeah.
And then in execution of your vision, what were the major challenges that you came across?
So getting the robot to turn nicely on these markers, actually surprisingly difficult. To get the robot to enter the turn, make the turn nicely, and exit in the direction that the marker is pointing consistently, in a consistent way, surprisingly complicated. We had it all tuned up. It was all working great. You then put payload on the robot, and it wouldn't exit the turn correctly because it was developing too much angular momentum going into that turn. So figuring out how to make it work in all configurations and all payload conditions. I mean, I wasn't planning on demoing the robot today. I just came today to try it out in some different and weird lighting conditions to make sure that it would work in those sort of circumstances. So yeah, those kinds of issues, those sort of corner cases were the biggest sort of problems. Getting turns nice, making sure that the markers are always viewable in every lighting condition, weird, whatever situation there is. If there's dust on the floor, those kinds of issues were the biggest challenges, right? Yeah.
What do you use to measure how far it's turned? Odometry or some other sensor?
The way it works right now is that it goes into the turn purely on odometry, because as it enters the turn, when it enters the turn, it stops seeing, at some point, it stops seeing the marker. Because the turn is designed so that, if you can imagine a point in the middle of the marker and a point in the middle of that marker, and a point in the middle of the next marker, the turn is designed so that the robot will follow constraints. You can specify how wide the corridor is that allows you the robot to sort of cut corners, as it were. And when you specify how wide that corridor is, then it computes what the curve should be like to stay within that corridor width, the angular momentum limits, and so forth. All of those things are computed as it goes into the turn, so that you get a nice smooth turn under all weight circumstances. So yeah, obviously you don't want it to have a zero width, because then the robot just comes into the marker, stops on the marker, turns, and then exits. We wanted to try to make it a more smooth motion, so you then wind up saying how much can you compromise and what are the constraints.
And is it really limited to 90-degree turns, or can it be any?
Do any turn you like.
Okay.
That was another thing that caused a lot of problems, because you tuned it up for a 90-degree turn and then you put a 30-degree turn in, and the turn would work in some circumstances, but not in other payloads. So that matrix of every angle, every turn degree, that proved complicated to get working just right.
Yep.
So
what is the field of view and range to see the next marker?
So this, you've got a Raspberry Pi 2.1 camera on here. It's a regular Raspberry Pi cam. So we can see about 60 centimeters in front of it, all the way out to about 3-4 meters in front of it. Is roughly what it is. So yeah.
So how much misalignment if it doesn't come out of the turn directly at the next marker?
It can quite easily cope with being a meter off. The robot itself will not be a meter off, but the point that we wanted to have was you could just sort of slap these markers down. You didn't have to particularly aim them, and it would still work, and it does. So the lateral alignment is usually not a problem, and it comes out of the turn at the right angle these days. But the key thing is, can you have the markers broadly misaligned so that the user doesn't have to spend out? On our original marker, we put actually alignment marks on it so that you can precisely align it. But our goal is to have something that's simple enough to slap these markers down, and you don't really have to spend a lot of time thinking about it, and it all just works.
Are the markers nicer than just paper, David?
Okay, yeah. So these markers are just paper ones, but what we usually use is a certified floor sticker, and then that is laminated with an anti-slip surface and yada 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 yada.
Is there any meaning to the Rorschach test in the middle?
I don't know. I mean, I think this one is
Bringing back a repressed memory.
yeah, that one is definitely
But the robot's not getting any
very
reading out.
repressed memory. Yes. This is the screen right here. So yes.
But the robot's not interpreting that in
The
any way.
robot is not interpreting that at all. But we did find that the S-tag markers, these S-tag markers, are more robust than your Aruco markers or other alternatives. We evaluated several different types. And this type will function quite nicely even if corners or edges are obscured, which the Arucos tend to do less well at, because it looks from the outside in. And this marker library has about 20,000 different markers on it. And the Aruco, the performance, you can create a 20,000 marker library with the Aruco, but the performance tends to degrade when you put a library that big, because the yeah, we won't go into why, but it does tend to degrade. So yeah.
And this is not slam. For anyone who-
Yeah, this is
not slam.
What happens when it has multiple projecting markers?
Great question. Really, really great question. The system was designed so that go markers in opposite directions, so you could set an outbound route and a return route in opposite directions. It would ignore the go markers coming in the other direction. That was how it was set up. It was also set up so that the turn markers, it only follows the turn markers in sequence. So what it will do is it will look for a valid go marker, that's to say a go marker pointing in the right direction, or a turn marker, the next turn marker that is in sequence. So it will follow the next turn marker in sequence if it sees it, and it will then follow go markers that are oriented in the right direction. And it will always follow a stop marker if it's in the right direction. So the point is that the idea is to be intuitive. You can set up a very large route, mostly with go markers, and only use the turn markers when it's necessary. And then what will happen is that if you do that, the robot will come back and it will only follow the turn marker in sequence, so that you should try to avoid these conflicts. Still possible to it's still possible to create conflicts, it's just quite difficult. So yeah, and the robot tries to interpret it in a sort of sensible order. All right. But that's a really, really good question. And it's one that we spend a lot of time thinking about, and actually tried various different things and found that some things really did not work well. And still, I think we're still putzing around with exactly how aggressively should it ignore a turn marker going in the wrong direction and pointing in the wrong direction, things like that.
And we also have to go from kinetic to noetic, skipping melodic during this. And that's the Python 2 to Python 3. So lots of little irritating pieces of code to fix.
Yeah. Okay, any other questions? Well, thanks very much, guys.
Who's next?
I think just putting the phone on the mic that way was working really well.
Yeah.
Let's just do it.
Okay.
Okay.
I just see if people can hear you.
Okay, can people hear me? I don't know what happened.
People on Zoom, can you hear Wayne?
Yes.
Okay, that was a yes. Okay, so do we have any other robots to be shown here tonight?
We got some stuff online.
Looks like a no.
Camp said stuff online.
Okay, so now we're going to go switch over to online. So I'm going to sign off here and until the online section goes away, and then we're going to come back and we'll start any of the presentation talks here. Okay.
Okay, so we're going to do
So
the
take it away.
show and tell online. Hey, Chi, are you out there?
Each time Camp is talking, it's not coming through.
Chi, are you out there? I don't hear from Chi. Who else? Who has a robot for show and tell online? I do. Let me share my screen. I shall go for a full pull Floorbot Challenge Phase 1. I'll use the navigation 2 tools, waypoint mode, navigation goal, point, press, drag, mouse up, point, press, drag, mouse up, point, press, drag, mouse up. And then I'll go back to this location where I was. Let's start the navigation. So it's not following any of my navigation. Let's try this again. Navigation 2, let's cancel that. And let's set it for waypoint mode. And navigation 2, navigate. This is waypoint mode in navigation 2. So let's see if it works this time. And start navigation. There it goes. So this is autonomous, and this is full stack. This has got the mapping with the bot vac, and I've got ultrasonics on there. Whoops, he's getting badly delocalized here. My demonstration has gone completely awry. So I'm going to stop it. Who else has a show and tell out there? Who else online has a show and tell? Speak up. Does anybody else have a show and tell? Well, if not, I'm going to give this one more try. So there's the camera with the standard USB. And let's go nav 2, cancel waypoint mode, point press drag, and a third point. And now let's start our navigation. I'm cheating, I'm dragging it actually. Let's just reset and do just a regular navigation. Well, I'm not having any success here. Anyways, as you can see, the camera's working. There we go. Anyways, that's enough of that. Who else has a show and tell online? Does anybody else have a show and tell online? Chi, are you out there? I don't see you. You were saying you had a show and tell, but I don't see you right now. Okay, this is the last call. Does anybody else online have a show and tell?
Camp, can you do a beauty shot of your robot?
I can do that. Let's see here. Bear with me.
Camp, I have something.
Okay, hang on a second. Let me get this beauty shot in here as best I can. Flip this around.
We said beauty shot.
That's the best beauty shot I got. Can you see it? Testing 1, 2, 3. Can you see it? Testing 1, 2, 3. I'm talking
Yeah.
so that it's good.
Yes,
Hey,
we can see it.
Chris, can you spotlight me? Otherwise, Dan, did you get what you wanted there?
Yes.
I think you need to lean there and smile a little longer. Just,
I'm done.
until
I'm done.
your back goes out.
I sensed an air of sarcasm in that statement. Who else has a show and tell?
I've got something. It's not 100% working.
As if mine was. Tell us about it.
All right. So this is Ryobot, mostly because it's Ryobi green and uses Ryobi batteries. And the idea is it's going to be a telepresence robot. So I have a Raspberry Pi screen, Raspberry Pi 4. I was trying to cheapen out and go with some really low cost steppers, but my place of work had these smart motors sort of sitting around in a basement not doing anything. And these are like $2,000 motors each, but they've got full encoding. Unfortunately, I just moved onto a new computer, so I can't get this running right now. Everything's controlled over serial.
Ryan, are you online or are you at the Maker Nexus?
I'm online.
Okay. Very nice.
These
I like
are skate wheels, adult skate wheels. I think
You
they're
say
the biggest
skate-
ones.
You say skate wheels.
like scooter wheels.
Okay. And what have you just got gear motors in there?
These are encoded steppers, but they're
Fascinating.
really, really torquey.
Is that a DB15 there or a DB25? What is that?
So these are like special DB connectors, and then there's a DB15, I think, just
Okay.
for IO.
Yeah,
So
you know, no, old
they've got
school.
a microprocessor inside if I wanted to use them, but they're from like
Oh.
2007. So the communication is pretty old.
Is that your motor controller?
Yeah, it also doubles as a motor controller. So it actually turned out to be a cheaper way to do it.
Hmm.
And then I've been running it all through Python. So I adapted something that ran on, the motors run on Visual Basic, and then I'm using communication protocol to reprogram them with Python.
I've got a question from Maker Nexus. How much of that is 3D printed, and do you have anything you can say about that? Is that heard? Did you hear that question?
Oh, all of this is 3D printed. So the entire housing, the entire chassis is 3D printed. The back of the unit of the Raspberry Pi screen is 3D printed. The wheels aren't, but slowly this chassis will become one piece with the screen. I think I maxed out my printer printing this.
Could you share a link to the Pi screen frame?
The screen frame is something I just printed. I designed it myself.
Did you get that off of Thingiverse, or did you do that
No,
yourself?
I did it myself.
Oh, okay, nice.
I tried to go back to basics and just do everything from scratch. I didn't want to base anything off of something that
Right.
previously existed.
Very nice. That really looks great. What else we got out there in show and tell land?
I have a, I mean, I can show.
Steve
pictures of
Dillo,
my
go ahead.
I can show pictures of my robot or a video or something. I mean, this is like my rover that you've all seen. But it's 3D printed. So give me a second here and I'll share a video on my screen. I gotta, has everybody here seen the music video that I made for the rover a while back?
Just go ahead and kick it off.
Okay. Hold on. Okay, and let me share my screen here. Share screen. Okay, can you see that?
Yes.
Okay, here we go.
We're not hearing the music.
Oh, okay. Hold on then. I don't know.
I think there's an ellipsis in the upper right that says share music or share sound, something like that.
In the upper right, share. No, that's a share link. Pause, share more.
How about that little deer?
Settings. Oh, share computer sound. There we go. There. Oh, and I have a new little icon up there. Okay, so let me just
wind it back here and try that. How about that?
You hear it.
Here we go.
It was better without the music.
Let me turn it down a little bit.
Very nice. Are those treads printed in CPU?
Yeah. And they kind of slide on, slide off.
Very cool.
So all the bright green stuff, all the black is all 3D printed.
And what do you do for separation of responsibility between the Pi and the Jetson?
It's all the Jetson is running. It's all running ROS, but the Jetson runs purely Vision Topic.
I got that.
So the Pi does I/O and basic, electronics.
Very nice.
Let me stop sharing before it takes me off somewhere else.
Thank you very much,
So
Steve.
not a problem. Oh God, hold on. There we go. The Pi. Hold on. Yeah, let's close that. There we go. So just to answer a question, the Pi runs the ROS master and runs ROS serial and listens to the controls the dynamixels and the motor controller and a lot of the other like has some battery sensors that you saw, like a battery monitor and stuff like that you saw on there. The Jetson just runs Vision. And now that was an Orbic Astra on there in the video, and that's been replaced with an OAK-D camera. So
Very
the
nice.
Jetson is just doing the camera stuff.
Very nice.
Steve, I've got a
Very
question.
cool.
Is that autonomously driven or is it remote control?
Now it is. It's actually a mix. I have another video of it doing autonomous collision avoidance. So it's mostly teleop driven with a PS3 joystick, but there is some autonomy. I'll post a link in the chat of a video where it's like I have it doing a Turtlebot follower where it's following me autonomously, and then I also have like a sonar aware teleop where I'm still joysticking it, but it does collision avoidance. It takes the sonars that you might have seen on the front there, and it uses that to avoid obstacles. So I could like in the video I'm like pushing it at a wall or at like some file drawers, and it steers away from them.
Steve, I have a question for you. Can you hear me?
Yeah.
Your steering is done through the 4 Dynamixel servos.
Yeah.
And how you controlling the Dynamixel? Are they run from the Pi or from the Nano?
Yeah, there is. They're running from the Pi. There's a. I have the USB to Dynamixel USB 2D interface, And that's plugged.
Are you using the Dynamixel device that, because I have the same problem, but I'm running my Dynamixel for a robotic arm off of an Arduino Mega. And actually Dynamixel makes a hat to control, and I'm using that. It's an Arduino hat.
Yeah.
But you know, I haven't been able to make it work yet. So I was curious to know how you controlling your.
So there's I have it. I don't have that hat. I have the USB 2D interface, which is a USB to serial, like the half duplex serial with a little interface board, and that plugs into USB on the Pi. The other thing that I've made sure that I'm doing is that I have the Dynamixels plugged into a power board. So they have like a separate 12-volt power, and that gives them enough power that provides enough power, enough current for the 4 servos to work reliably. If you just try and do it off of the Pi or the Arduino, it's just not going to work.
So you do not have encoders. You don't have encoders. The Dynamixel are sending back their information about their position.
Right.
Without an encoder. Actually, they're built in the Dynamic. Are you using
Right.
the AX12A?
Yeah.
Okay, thank you.
Yeah. Let me see if I've got a picture here of what the insides, because it's all kind of like on the floor of the robot. See here. I'll post that in the chat. So I'm running like the joy node, and then there is like a Dynamixel steering that so it's all ROS, and it's a Dynamixel steering node that I kind of hacked together myself from the one of the ROS controller. There's like the ROS controller package, and that's sort of like a generic how to write a controller, like a motor controller or a motor controller interface for ROS, and you kind of have to write your own. So I did that, and that talks to the AX12s.
Are you running ROS 1 or ROS 2?
I'm running ROS 1. I'm running Melodic on the rover because there were a lot of things when I was working with the software stack and getting it stable. I was first getting that running. I had Kinetic on there for a while, and then I switched Pis from a Pi 2 to a Pi 4. And so I started using, I moved up to Melodic. And I could probably go to Noetic now, but it's there was a lot of, I just went up to Melodic because there was a lot of things certainly in ROS 2 and also in Noetic that weren't like entirely cooked yet.
All right, folks. We've got a lot of 3D.
Oh, we got a lot
printed
of,
stuff
okay,
out,
yeah, I gotta
so
go.
we need to
All
get
right.
moving. Is there any other, are there any other show and tell items out there real quickly? Any more? All right, let's get on with the show then. Stephen Williams and our 3D printing roundtable. Thank you very much.
Yeah, it's just somebody got me.
Al, the camera's not right.
Whoever's controlling, can you take the spotlight and put it on my iPhone?
Yeah, damn it, you're gonna need to turn your video on. I can't spotlight it without a video.
Yeah, I'm having trouble getting to it.
Yeah. Can you mute? Have you muted? Can you hear us, Camp?
Yes.
Okay, I think this is working. Rohan said to use one computer so that the Zoom echo suppression works. And that's why we're not hearing it, because you can hear me, but they can hear us over remotely.
All right. All right, I'm Stephen Williams. We have a whole lineup of interesting discussions about different 3D printing experience and projects and things that people have done. And this will hopefully be a good introduction to considering whether you want to get into 3D printing or and how deeply and how quickly and what really we started out talking about 3D printers and 3D printing. And we quickly realized that a lot of what you really want to solve is actually creating custom models. So generally CAD programs of some kind, usually mechanical CAD, so MCAD. And there are a number of options that are not highly overpriced commercial options. And so we're going to talk about a number of those tonight, because that's kind of you get a 3D printer, you can download and print a lot of interesting models. And then for most of us tinkerers and engineers, we're going to want to design and build our own things. So we'll talk about that a little bit. So first up, I believe we have Scott. And so let's see if we can switch up. I think he's online.
Is online. Chris, can you spotlight Scott Monahan?
Yep, I'm here, and let me I don't have my camera on, and actually let me share my screen. That's really what I want to do. One moment. I only have one screen tonight, so I have to figure out how to do this. Share screen, the big green button. That should do it. All right. Let me all know when you can see my screen, or if you can see my screen, and if you can hear me.
We can see it pretty well.
And we hear you.
Okay, cool. So one of the first things that, I've been 3D printing for about 4 or 5 years. I got my first 3D printer, which was a real, almost like a toy. And I was just working on little tinkering projects. And the first thing I wanted to be able to do was be able to create models, and for myself. And I have experience in Photoshop and Illustrator and those kind of programs, but I never worked in 3D before, and I had no experience in CAD. And I had tried back then to get started. I tried a little bit with Fusion 360, and it had a really high learning curve, and it was really frustrating at first. And I actually do use Fusion 360 for Robot now. I've gotten it figured out, but that's in large part to really starting out with this tool called Tinkercad. And Tinkercad is great. It's just you go to tinkercad.com, and it is 100% web-based. And what it really is designed to be intuitive, almost like, an exploratory baby's toy on being able to really make, really get right in there and within an hour be able to make something real. And, I got in here and I was able to, print stuff right away. And my first robot, this is Alice, the first robot that I had, which was Alice worked with the input from an Xbox 360 Connect, and it would look at my body motion, and then Alice would copy that body motion. So you I would be able to put a visor on my head and be like Alice. So she was called Alice because it was like shrinking down, like in Alice in Wonderland, and it works fairly decently. And but the cool thing is I was able to do all of this on Tinkercad. And so what I wanted to do tonight is just kind of show how the main concept of Tinkercad in a like a real quick 5-minute demo. So here's, this is like the advanced stuff that I was eventually able to do, but I want to show you kind of the idea of how this works. So you log into Tinkercad and you create a new project. And the whole idea is you can take these shapes, which are primitives, they're basic shapes, and then you can either have them be solid or you can use them as a tool, as a hole that will put a hole in another shape. And that's how you take the shapes that are here and you can shape them, you can form them into other things. So what I was going to do is make a little 3D printed smiley face super fast and show how easy it is. So first thing we're going to do is grab this half sphere here. I'll make it about 7, about this size. I see we've got it. I'm going to make it a nice even size. So I'm going to go down to like 60 by 60. I like that. And if we want, we can take a look at it in 3D. And what's nice is the site itself is all 3D accelerated. So if you have a 3D card on your computer, everything's super smooth. So we've got just this half face. And what I want to do is give it 2 eyes and a mouth. So first thing I'm going to do is I'm going to grab this cylinder here. All right. And what I basically want to do with this cylinder, I'm going to make this a little bigger. I want to use this cylinder to drill some eye holes through this. So I go over here and I can just take this guy this big and then stick the eye here. And then I'm going to copy it and put another one right here. And then I'm going to grab this little half moon guy and I'm going to make that the smile. So I want it to be a little bit bigger, a little bit wider, and I need to flip it. So they've got this nice, it's really easy to you can either snap or go smoothly, and everything's really intuitive. Just like playing around with your mouse with this thing. So see, to cut through it, I need to make it a little higher. So I'll go like this, go back to my top view and get this here. All right, that looks like a smile. Now I need to take these solid shapes, and instead of having these solid shapes be here, what we want to do is make them tools that drill through. So I'm going to click this button here, and that changes it to a hole. And so now I've got my 3 hole shapes. I've got my original shape, and I can select the whole thing and just group it together. And this is the part that's magic, is once you group it together, it makes it all one part. And you can see I've got my smiley face here. And I didn't cut all the way through for the mouth, but I don't hate that. I think that's okay. And so say I wanted to print this and give it to my daughter in the morning. All I have to do is I select the part and I click export. And kind of the standard that you would get from like Thingiverse or whatever is this STL format. So I'm going to export to STL and I'm going to put it on my desktop here. And then I'll just open this up. And I open this up in a program called Cura. And somebody will also probably talk about this as part of the 3D printing roundtable. But Cura is a program, it's called a slicer. And what that does is it takes 3D models and STL and other formats, and it allows you to turn that file into something that your printer understands. So it's got, now you can see here's the face, and what I could do is I can click slice here, which would get it ready for printing. Now it's going to say, okay, this is going to take me 3 hours, 38 minutes to print if I wanted to do it. And if I want to see, what it would look like as it was printing, I can see, layer by layer here and look at that in my slicer. But, the important thing here is like how easy that was for Tinkercad. And I showed like the most simple thing you can do. But there are, and then I showed sort of the most advanced stuff I did. But there are folks that do some really advanced stuff in Tinkercad. There are some people who like swear by this tool and eschew, Fusion 360s and other more professional tools. That said, if you're intimidated by, you know, the idea of 3D printing, I would say just try out Tinkercad, and it's a lot of fun. So just, you know, with that, I wanted to keep it short. Any questions?
Say, Scott, doesn't Tinkercad have a slicer in it?
No, well, I don't know if Tinkercad has a slicer in it. I haven't used Tinkercad for my own stuff for about a year, but I don't think it has a slicer in it that I know of. You can there's different places you can export, but this is in generally for 3D printing. You would create your model in one program, and then you would export your model into a slicer, which will allow you to set all the settings for your printer, how you want to do it, and it will be, you know, it'll be specifically set, you know, for your printer. Like, for example, I would use you would use a slicer if you were like my printers are all basic FDM printers. They use filament, and then they add a layer at a time. But then there are resin printers that you could use your slicer for. Basically, the slicer is the program that, you know, prepares your model for printing.
Very cool.
Any
Very
other
nice.
questions? Oh, thank you. All right. Well, I didn't want to take up a lot of time because I know that folks, it's really easy to do that, and I want to give everyone a chance. So if no one else has any questions, I'll stop sharing my screen and we can go on to the next folks.
Thank you very much. That was awesome. That was a really good introduction. So we have a presenter list that's listed. We could go ahead and go in that order, or we can do all the CAD. So let's go with Kevin Chow next to talk about Ender 3 Pro, CAD, and some of the projects that he's done. Are you ready, Kevin?
Yeah, I'm here.
Okay, excellent. So just remember, we have a bit of a lineup, so we don't want to take too much time, and take it away.
Yeah, I've got a bunch of things to show. Like, so yeah, like for the CAD thing that I use, like, I don't use Tinkercad, or I guess I don't really use 3D either. I use this other CAD thing is called Onshape, which is I guess it's a bit similar to Fusion 360, except it's all browser based. So like it's you just log into like any web browser and then use it from there. And if I could share my screen.
Forgive me, why don't you take your mask off? Because if you're at home, you don't need it and we can hear it better.
I'm actually not at home. Like,
Oh, okay, that's fine.
I share my, yeah. All right, so yeah, this is what I guess Onshape looks like once you log in. And there are like a few things that I designed so I can show you pictures of. Like, I got like this servo holder thing that I made before to, it's basically holds this servo in, and when it's like placed in, it kind of looks like that. Just add a few screws, and it's a bit snug in there and doesn't fall out. And that gets used in, like, I'm trying to build this walking robot. It's still a work in progress. But basically, it's just a four-legged robot, and I decided to stick on electromagnets onto it in hopes that it would like cling onto magnetic walls of some sort. But yeah, anyway, for like one of the servo holders that I made, I can show you what that looks like here in Onshape. It pretty much looks, once this loads. looks pretty much like this. So it's got like a bunch of holes to like fit all the screws and some nuts in as well that to hold the other piece of the servo holder. And on here on the left is all the bunch of like sketches and extrusions like I made in order to create this piece. So it's just a bunch of them. And yeah, and in order to print this out, I have like an Ender 3 Pro at home. Since I'm not actually at home right now, like I can't really show you, but this is what the printer pretty much like looks like. It's you know a cheap printer that you can get. I got mine off Amazon, and mine looks slightly a bit more cursed than this because I kind of replaced a few parts here and there. But yeah, once like I got my model off, finished, I pretty much imported it into Cura. So I open up Cura. It loads. Not sure why it's not loading.
Because it's a live demo.
Oh wait, now there's yeah, my computer's a bit slow sometimes, especially when I have a bunch of things open, I guess.
And doing a live demo.
Still loading. All right.
Is Onshape open source? Is it free or do you pay for it?
Yeah, it's free for personal use. But the catch is that like everything you do is all public. So I guess like that probably isn't too much of a deal for like I guess most hobbyists. Like but if you were looking for something like private, then you'd have to like upgrade to a paid version of Onshape in order to have private models stored on your account.
Yeah, my understanding is that Onshape was built by the guys who built SolidWorks or is connected to them, and it's basically, I think, essentially a web equivalent of SolidWorks.
Yeah, like the reason like I've been using like Onshape rather than like something like Fusion 360 is like Fusion 360 technically works on my computer, but it's like it's slow to load, which I'm not sure if it has to do with me having installed Fusion 360 on my HDD instead of my SSD, but you know, it's computer slow sometimes. But anyway, here is loaded, so let me show you guys what that looks like. All right, so it's what it looks like. The model loaded in. I would just like press slice, and it shows you like the time, and then I would basically what I would do here from here. If I was in front of my printer, I would pretty much save it to removable like SD card. And my printer in particular, there are some printers where like you are able to wireless connect to them, but for my Ender 3, I have to like put it on an SD card, plug that SD card into the printer, and then start the print from there. So yeah, and then I guess the preview kind of looks like this. So I guess it pretty much print like that. And these blue things, like here, that's like the support material that you would later, I guess, pop off after the print is finished. And I guess the support material is basically just to like hold up certain areas of the print where I guess like the software thinks that it would need help with when the printer is printing like through air or something like that.
Yeah, but you probably have M3 holes in there, so you wouldn't really need support for those.
Right. I guess like, I just by default it's in there for, I guess, for some reason. Like I could have like went ahead and like took those out, but I didn't. So yeah. So yeah, that's pretty much what I've got. It's got a lot of other like things I 3D printed, but like since I guess we're limited on time, then I don't want to take up too much time out of this to show them all. So, yep.
All right. Yeah, that was really great. Let's see. Lost my place here. Okay. Next we have Al Margulies with OpenSCAD, which is another interesting option.
Big Al.
Here behind you, and I'm going to try and show something on my screen. Don't know how well this is going to work because of my broken technology. But for those of you who think in code and find absolutely nothing intuitive about all of these intuitive GUIs, there is a solution. What I've got in my hand here is a little wall, HO scale wall that I'm building for a museum model railroad. And what I'm using is OpenSCAD. It does give you visuals, if you can point it at the screen here, but how you draw is entirely in code, which you can't see, but I'm going to do just a one-click demo. It's a procedural language. It doesn't have objects, but if you are a coder like me, you can write OpenSCAD code from Python or some other language and do whatever you want to do because it's just code and you don't have to figure out how to click. What we've got here is a wall that's 7 feet tall right now. I'm going to just, because this is all code and everything in variables, I'm going to change that 7 to a 4. I'll click up here. And the wall size changes because that's what code does. So this is how I do my drawing, my 3D printing. And that's the end of the public service announcement.
Can I say something about that? If you use Fusion 360 and you use parameters, then you can do the same thing by simply making a drawing, fixing your parameters, the length, width, height, size of holes, and etc. You go back into your parameter list, change them, and boom, you're.
Yeah, there are a million ways to skin a cat. And we have lots of options. That's what tonight is about. And you pick the one that works for you. And I just like this pure code approach. And as Mark Johnson just pointed out, there are libraries available with bunches of pre-written code that do things like draw screws for you with.
I would just like to add that I'm one, huge OpenSCAD fan, and two, I think the real power of it is once you get particular building blocks, say like a gear or a mounting bracket or something like that. Once you get that coded up and you get it in like a single example that you like, the real power is because it's code, you can, make it iterate. You can do like recursive functions and have it generate like a dozen different, mounting brackets with different screw hole sizes and spacings and things like that. And what I've done in the past is I've done that. I've, generated like a dozen with different parameters, printed that out. And then I have like, a bunch of examples and I test fit them or figure out like which one works best, and then, you know, toss the others and stick with the one. So that's like, I think, one really cool thing that I haven't seen be too easy in other CAD programs, is the ability to just generate out like a bunch of different variations really quick, and then export it out as an STL, export that whole thing out as an STL, and your printer will just print them all as one file.
Right. So do you have any other questions or comments?
I was just gonna comment.
Yeah, I was just going to comment about one of the things about SCAD that is.
Hang on.
We doubled. Okay. Then just point out about SCAD is that it's Git friendly. And so you get really cheap and easy revision control, which a lot of the things like SolidWorks and so forth, the version management and multi-user story is pretty painful.
Was there something else?
Chris?
Okay, I'm going to hand it back to our
Well, hold
MC.
on a sec. Can you guys hear me?
Yes.
Yeah, I wanted to show off one of the cool features of OpenSCAD that I use a lot, and that's the animation feature.
All right, go for it. Let's switch to you.
So I'm just
Say,
gonna
Al,
share my
the
screen
cam-
really quick.
Al, the camera that's at the Maker Nexus is pointed to nothing, or the wall or something.
Just stick to Dan's when you want the room.
Yeah, can you switch to Dan's mobile?
Well, this is Chris.
That-
Let Chris go.
Yeah, Chris is gonna show off the animations.
Unfortunately, because I'm sharing, I don't know how to unshare because my main window is gone. So I'm stuck sharing for the rest of the meeting. This is not good.
Can you escape or?
Go to the, I believe the top. There, show up a little top middle.
There we go. Sorry about that.
Technology is great when it works.
Oversharing again. All right. Let us know when you're ready, Chris.
Oh, I've been ready. I guess
Oh.
I thought I was preempted. You asked me to stop sharing.
Oh, no. I didn't mean to.
Okay, let's go back. This is just a simple model that I made because I use the SG90 servos quite a bit. And this is a good example of what he was talking about, just the code. And it's basically cylinders, cubes, and you can translate and rotate them. But one of the features I really like is if you click view and then click animate, you can type in frames per second and a number of steps, for example, and you can actually animate your designs. It has a magic variable $T that you can use to scale, rotate, and translate stuff. And basically, it's just a variable that you can use in any function you want. And I use this a lot. Whenever I build something, especially if it's going to be moving. So just view, animate, and I get a blank black screen. So
Zoomed in too much, maybe?
Murphy.
there we go. So we can go view, animate. Let's try that again. View, animate, and type in our frames per second. Let's go for 100, 100. And so this is going to animate. Let me see if I can center it there. And it's just a really cool feature, so you can see what your design is going to look like with the other parts as it's moving. So I just wanted to share that animation feature off.
Yeah, pretty cool. I think OpenSCAD is really compelling for certain kinds of parts. I think, and I think other kinds of design where you're designing something curvy with bevels and other things, I find it difficult to think about how to do that in code. So I think there's probably, I think in a lot of projects you could probably do some certain things with OpenSCAD would probably be a lot better. Things like a screw or a gear or things like that. I kind of wonder if you probably could export the STL and import it to merge it into a design that you build with a more UI based tool. So, okay, next on our agenda. How about Wayne with FreeCAD? Oh, okay, no problem. No. So, oh, I'm sorry. Yeah, we had you on the list here, but that's a miscommunication. Sorry about that. We already did Tinkercad, so let me go ahead and Chris, you want to do a little review of Fusion 360 or Chris Albertson?
I don't see him online.
Okay.
I don't see.
All right. And how about Lorene and
I will. Sure.
yeah, how about you go next?
Okay.
And then I'll follow her.
Yeah, perfect.
And can do a Fusion 360 review. How do you share the screen now?
Oh, it's not there.
Oh, share screen. I
There you
see. Is this one? No. This one.
Right here.
No, this one. Because we're gonna move this over here. Insert. Oh, and we're gonna switch. There we go.
Can you see it?
Yes. How many end moves do you have?
Well, our family has made 4 in total.
Oh, we're sharing the screen.
Oh, you're right. We are sharing the screen. Okay. So we have 3 at our home right now.
Uh-oh.
Okay, that's interesting. Okay,
yeah.
we're fine.
All right.
Okay, go ahead.
Okay, so yeah. So like in the beginning, when my mom got like the 3D printer, I was in 8th grade because I begged her to do it because I saw the magazine of like Gail Langevin making the humanoid, and I was like, hey, I want to do that. And so like I remember the first print on the Let's Spot Mini was a little octopus. It was so cute and tiny. And then my first like real project was the humanoid head, as you can see. Oh,
it's okay. We can do.
Okay. All right. And so after that, I learned a few 3D printing skills from making in move, like loading and starting prints, filament, all that jazz. And yeah. And so, I mean, with one like mini 3D printer, printing all the parts for InMove took a while. Because like each print took like an hour or so. And so, but prints would very rarely fail. So, I mean, that saved us a bit of time. Not having to worry too much about that. And so when my mom built this hill project, the animated hill and valley where the robot's going up and down, I love that one so much. She realized, if you can see all the squares in that, those are all like parts that she printed each one, and then she put it together like a puzzle piece. She realized that her printer was way too small. And so she got a bigger printer. And yeah, she built a tree, and she also built a welcome bot with her bigger printer. And since there were now 2 printers, we could print more quickly for larger projects because we would have them both working at the same time, which was awesome. Oh, and then with Hikami, we worked with him to make this much larger humanoid, which is really awesome. It was super tall. In terms of like in-move humanoid scale of creepiness, I think this one was the only creepy one because it was super tall.
Okay, that's debatable.
Okay.
It looks angry.
What?
The in-move looks angry.
It looks menacing. Yeah.
And it's not even on its scooter.
Oh, on a scooter, it's even taller. It's like, what is it, 7 feet on its scooter?
Yes.
Yeah. It's even taller than Grandpa, and Grandpa's 6 feet tall.
Yeah.
As you can see. And so, yeah. That's the end of my presentation.
Very nice.
That's really amazing. Thank you.
I'm walking off into the distance with my robots. I love it.
Are there any other questions for Lorene before we transition to the next? No, I'm gonna share this one.
Oh, right.
What's next, Lorene?
My mom is next.
Well, I mean, what's your next project?
Oh, my next project is university.
Yeah.
Perfect.
Robotics engineering, by the way.
Very good. That's awesome.
Excellent.
Choose wisely.
Thank you. Thank you.
Yes, you are choosing wisely.
Yeah, I feel like my whole life was leading up to this.
and funly.
Yeah. Do you know which university you're going to?
ASU.
Okay.
Yeah.
Very good.
Yeah.
Yeah, we're leaving in a week and a half. So
Wow.
road trip.
Oh, really? It's gonna be hot.
All right. So that's amazing. Congratulations.
Thank you.
All right, Dee Dee, you wanted to show us some things?
Okay, yeah, and I will, let's see, I thought I will share my screen again. And I will cross my fingers to see which screen shares. Okay. Select the windows you want to share, but don't show me the window. Okay. Oh, there we go. Screen
So
two.
you say ACS, ASCL?
Yes.
Where is that? What school is that?
Oh, Arizona State University.
Okay.
Arizona, yeah.
Yeah, it has a polytechnic because ASU is a really big school. The engineering school is a big school. So I was surprised to see they actually have a breakout major that's specifically robotics engineering. And so that's, you know, in addition to all the classical, you know, EE and CS and, you know, so that's what she picked.
Yeah.
So it's exciting.
Very good.
Okay, so I was going to go over first a couple examples of before and after 3D printing. So I don't know if you recognize this, but this is the Radio Shack kits, and you know, you make the Radio Shack kits, and it's definitely interesting. I think the things I really enjoyed is you can also, in addition to printing, designing your own and downloading, like here's just a 3D printed wheels, and then you buy the rubber gasket, and then you put in your own electronics. Or here's a ball robot. Back when BB-8 from Star Wars was popular, then you have to make the ball robot, and then you make the little attachment for the head. So that's very different from what you would typically pick out. So, and then here's before, after, before versus after on the arm. I mean, there's like, you know, multiple models you can pick from here for the arms. And, you know, different types of motors. You want a micro motor arm, fine. You want a standard servo motor arm, fine. You want a dynamixel motor arm, fine. You got all those options in addition to designing your own. And this is nice because, you know, the Spot Micro versus the old school where you just hot glue gun 2 servos together. Nice. It's really neat, the open source availability of these Spot Micros, and lots to choose from and lots to customize in your own way. You want to add a lighter on top, go ahead. You want to customize the design, fine. You want to add an arm on top, go ahead, and the files are there. Some people have designed their own, and then you can build. I think the exciting thing is to build on top of what's already been designed and customize it. So exciting. Oh, I think this was an example of customizing, right? I have a Turtlebot 3. It's already doing the navigation. How about I turn it into a social robot? So I take out my calipers, add some eyes, some arms, plug in, add some lights for the mouth. And in addition to finding its way around the living room, it's also running ROS and trying to be friendly. So
did you build that dog?
Yes, I
Wow,
built
that's new. Is that Robots on Ice? Was that where that was?
Yes.
Yeah,
Robots
that's where
on
it is.
Ice. Yeah. So, and what was cool, because the Girl Scouts were like across from us, so they'd come by to our table and we'd start getting a discussion. It'd be neat. I would just take off the covers. And I see this is a Raspberry Pi with just a motorboard and servos. You know, you know, you could do it too. Just start with the Raspberry Pi. And so to be able to take off the covers and talk about the guts inside to make it more accessible to kids, you know, I think for me is just exciting in terms of, you know, hey, so I've, you know, gotten a lot of like, okay, yeah, it looked intimidating, but now that I see what's inside.
What I want to see is the big, tall, in move walking the dog.
It's like a chihuahua.
Yes.
Yeah. But not as aggressive.
So I will put that on my to-do list. And I
That
will
would be super bad.
That would be interesting.
That brings Skynet, sure enough.
So this is the reason I bought a 3D printer. I just finished a Maker Faire hacking a bunch of Elmos and other stuff with my kids. And I'm like, okay, I want to get on this project. And, you know, this looks very cute, but it's, I just wanted something a lot more polished. So I ended up doing a combination of this one, I think is from Adafruit, and then I have my own electronic boards with the PCBs on top, and then I have my own design for the arms over here. So it's just a merger of what I want, and then I make the little dress, and I connect it to a Raspberry Pi that's playing the videos and communicating with the Arduinos and the motor boards here. And then you have the kind of little power banks driving it in a nice miniature package. And they're doing YMCA and a whole bunch of other stuff. And I have a twins of those doing at the Maker Faire. So that's neat to go through multiple iterations, big and small, and get to that part. And then, so this is our setup. Technically, we have 3 printers, but we have an apartment, so we just don't have room for all 3. So, and you can see this is running our version of Cura in 2016. We started with the Let's Spot Mini, and Cura, and we used pretty much PLA filament. And I think back then it was really about, there was different brands of PLA, so then we get some inconsistency there. So once we got a good brand of PLA and cleaning the nozzle through, you heat up the PLA.
Did you name what brand of PLA you're using?
We have a couple. I don't have any off the top of my mind right now.
Is this the pit filament?
Oh yeah, Gizmo Dorks is an example.
Here, put it up to the camera.
But there's more than, there's a couple other brands that I go by. I think the quality
What
of the
brand is that?
Gizmo Dorks. But sometimes I just get the Amazon Basics, and that works fine too. There's a couple. No, I don't recall if Amazon Basics actually. Lutspot's a little weird because back in the day it was doing 2.75 nanometer filament while everyone else was doing 2.85 while everyone else is doing 1.75
nanometer.
No, millimeter.
Oh, you said nanometer.
Sorry, that's what my work language.
Yeah, I was about to say.
That's right. Okay, so it odd size, but there's a couple that I do avoid. But off the top of my head, I don't remember which ones. I could email it. Yeah. There's this even one from China that's called like eSun. I use those, and I typically do pretty well with that.
A lot of eSun.
Yeah, a lot of eSun. So once you find a selection of good PLAs, then you just kind of like, then I tend to have knot problems. And then bed adhesion early on, if it's like falling off the bed a lot, then I balance between a thin layer of glue stick, wipe it off. And so then I tend to not get that. And I also pay attention to the design, that there's plenty on the plate. Because if it's a tall design and there's very little on the plate, then you're gonna have to mitigate that. So, and then I think around 2018, 2019, given my big projects, I just got a bigger one, the Lutspot Taz. So I think one of the big things about keeping the parts printers running, for 6 years, I really enjoy the documentation. So there's plenty of things you can switch out. So I print parts as needed and order the other parts online. And then there's clear assembly guides for all portions of the printer. So I don't know if this is not common, but if it's not common, it should be. And so that's something that's I really enjoy and recommend. And I do like, the other thing is I do like that I think back in the day they used to be like the proprietary filaments, but here so I definitely don't like getting stuck into those. So you can use non-proprietary open filament, so that's great. So yeah, our sources come from 3 designs. The InMove was definitely an online design from a French designer, and modification. So here's this is the humanoid that went to Japan. So I modified it and I used some acrylic and some 3D printed brackets, and I think a little bit of Dremel here and there, and then you have a screen. And this is the humanoid that did the AMIL. So is that just a Windows computer? So it was doing the conversational thing for a while, discussion. They called me mom. And then this one is just a custom thing. And I like, even when you have big prints that I cut up into single pieces, multiple pieces, then I put a little extra attention into hiding the seams by having a faceplate. So like I cut this back part into 2 halves, but with the faceplate, you don't notice that it's two halves connected. Same thing here. And then design, I use SolidWorks in my university and early career. But at home, I started with 123 Design and then migrated to Fusion 360, and my kids use Tinkercad. So there's my son, and he did like a helmet thing. And then we just printed it in multiple colors, and then I glued it together, and fun for the kids.
Very nice.
Thank you.
Very nice. That's amazing.
Thank you.
That's amazing. I definitely need to show that, all of that, at high schools, junior highs and high schools.
Well, I'd be honored to give a talk, and I can post a link to the presentation.
Yeah, that would be. Yeah, that'd be really awesome.
Okay, I will definitely do that. I have a link.
Thank you so much.
Oh, my pleasure.
I'm very impressed. And if you want,
Yeah.
if you want
Just
to have some of the best PLA filament is this brand, Polymaker.
Oh, yes, I like Polymaker too. I agree.
It is also stronger than the regular Amazon or, you know, other type of less expensive brands.
Yeah.
Very good. All right. Well, thank you very much. We're going to run short on time, I think, but I'll race through what I have.
Sure.
But before I begin that, I'm moving right now and kind of shuffling things around and
Have fun moving.
well, I'm moving back to Sunnyvale, so I'm coming back to the South Bay. So as part of that, the only reason I mention that really is that I found a rep wrap kit that I had started to build, and my grandson broke apart, and then I ended up getting a couple nice printers, and I've had it sitting on a shelf. So we can, for the people here, if somebody wants that kit, let me know.
Al
the meantime-
Margalis, the standard camera is pointed to a wall or something.
This is what we were talking about earlier. Can you?
Whoever's running the Zoom call, if you can put the focus on my iPhone again, please.
This is what we were getting at earlier. I just mentioned it at an inopportune time. So, okay, so I can share a few things. So I will work on sharing my screen, and I guess we'll just do desktop. Booey.
Aren't you glad we put the camera on you now?
Yeah. So
You need another hand.
hopefully I don't have to. All right, that's okay. The Mac security thing caught me, so I had to restart.
Okay, while we're waiting, here's a picture of camp. Looks like a telepresence robot. Looking good, Camp. Oh, there he goes. Robot dance. Stop. Coming to get me. Nice.
We're easily amused.
So I'm coming back, but of course, when I restarted Zoom, it has to install updates. So of course, it didn't need updates a little while ago, but it. All right. Uh-oh. It is still not joining properly.
You still have the kick me sign on the back of Camp Robot.
All right. All righty. So let's go ahead and share this, and we should be good. All right. All right, that's not what I wanted it on. So, oh, of course, that went wild on me. Okay, so when I first was working on building some CAD projects, some parts for some robotics, I looked at Onshape. I looked at a number of things. SolidWorks is both too expensive and only runs on Windows, and I needed something that ran on the Mac. So I was really looking around. But as a lot of people have found, getting started with Fusion 360, the nice interface looks straightforward, and it's just hard to sort of get over the hump to figure out how to approach it. So this guy, Lars Christensen, I think is his name. I posted on the mailing list the link to his first videos, and that's really what allowed me to sort of get over the hump on things. So let me just jump in and look at a few of the things I've created. So this is one of my parts. It's part of a joint, and one of the things that we haven't pointed out, well, there's two things. You saw with Onshape this idea of doing sketches. So you basically create a 2D sketch. This is just literally on a panel. You draw a 2D sketch, and then you often will create offsets or offset constructions, is what Fusion 360 calls it, where you create planes that are particular angles, and then you create sketches, and then you usually do extrusions from those sketches or similar kinds of operations. Similar to Tinkercad, there are 3D solids that you can add to a scene, but for a number of reasons, that turns out to usually not be the way to do it. You'd usually want to create these 2D sketches on construction planes. And you can see here, if I turn these on, you can see the planes that I've used to create this. Right, so you can kind of see each of those planes, and then I created sketches on those and then extruded them in various ways. The other thing that's really useful in Fusion 360 that apparently a lot of other apps don't have is this timeline. You can use it for undo, and you can actually go back to any particular point, and you could actually modify any of these steps. So, kind of walk through, and you can see how I built this. And if I want to fix something or change it, I can go back to that point, edit it, and then just roll forward for anything that's still valid. And it turns out that actually is one of the most powerful aspects of this, where once you have it, you realize you can't really build complex things without it. So if I can get all this stuff out of the way, I can quickly switch over to a few other things. There we go. So this is a more complex model. This was kind of a joint idea. I had actually somebody helped me create this, and the important part is right here in the center, and these gears should, it's all kind of out of proportion, but it's kind of an interesting example of having an assembly with a lot of different parts. And what's cool is that you can see right now the whole thing is highlighted, but I can just highlight one particular thing, and then that guy goes solid, and everything else is sort of ghosts. And so you can kind of see how you can work with complex assemblies and sub-assemblies. And
once you highlight an assembly,
yes, yeah, you can print any particular part. Yeah, exactly. And each of these parts you can design right in here as a sub-assembly, and or they can be their own part that you import, and it keeps them linked so that when you open this up, it'll say, hey, you have parts that are out of date. You should update all the parts to the current versions, and then it will update this assembly. So let's see some other. So we were working on creating a haptics glove to remotely control a robot. And so this was sort of a quick sketch that just has a few items. You can see there's only a few steps here. Go back to the beginning. You can see I'm just kind of carving it, making it smooth. And so that wasn't quite what I wanted. So I ended up creating this and then created a whole set at different sizes and with different material. So, you know, you can kind of see. So you can see I've kind of drilled holes through this. The idea was to sew this to gloves, etc. And so then you can see I have a hand assembly where we're actually sort of placing all the parts on a 3D mesh that I imported, just to see how all that would work. And then here we have a whole head assembly. And what's interesting here is this has the circuit board inside there. Let's see. And so you can actually get the circuit board, the 3D model for the circuit board we were using that has all the properly placed holes to place inside this. And then I could design posts that would exactly fit the holes to snap the board into. So that kind of worked out pretty nicely. And let's see, is there another one? Yeah, so that's most of that. So the other thing I was going to mention that I thought is pretty interesting is that there is this project. Let's see if I can find it. Well, this is the GitHub for it. It's called the Positron V3. And it is an upside down printing compact 3D printer that actually fits into a filament box. And he's open sourced the whole thing. So I'm thinking about making them, and it's kind of an interesting project if you really want to go through the whole process of getting your own circuit boards and putting all the parts together and just creating the whole thing. It looks like just an awesome project. So
the printer fits into the filament box?
Yeah, this printer is super compact, will actually folds down and fits into the print box. Let's see if I can find here.
But is it not limited in the size of what you can print, or I mean,
Well, it's got to be a little bit. Yeah. So there you go. You're asking about the build volume. Here, let me go back and make sure that we can see that. There you go. Takes it out, unfolds it. It's got a heated plate that's upside down. So way bigger than the mini bot. And it's also faster than a lot of other printers. So pretty interesting.
what does that cost?
Well, you build it yourself, and it's they've sort of partnered with the JLC PCB guys. I think he did mention about how much it should cost, but I don't recall right now. So I'd have to dig through and see where he's commented about that.
It's okay. It sounds inexpensive.
Yeah, it's built to be fairly inexpensive, right? And just depends on whether you've used any interesting expensive parts. Oh, I remember that the drive for this is something I hadn't seen before. And I forget the details right now, but it's sort of like rather than a belt, it's sort of a like a knobby string or chain. And it turns out that it had been used in some other things. I just never had run across it. But he was able to use it here, and there were a couple of technical reasons why it worked better than a belt. And we mentioned the Ender 3. So I started the printer I really got going on was the Ender 3 Pro. And the interesting thing there, I don't know where I read this, but I'm doing some early research. I ended up deciding to start with PETG and rather than PLA, and partly because it had good mechanical properties and a little bit higher temperature and all of that. And that worked fantastic for me. So I now have an IDEX, and I will. Yep. Yeah, PETG. And PETG is really strong. It's stronger and not as sensitive to moisture and all of that.
Yeah, not as brittle.
What's that? Yeah,
Not
not as brittle. Not as brittle. Correct. And I was making a mechanical part. So this is my new printer, an IDEX, a dual extruder IDEX. Pretty. It's a lot less expensive than when I bought it. And right, I've been working to perfect not only CF nylon, because this can go up to 300C, but also CF nylon with a dissolvable PVA supports. And it turns out to be really tricky to get nylon. Nylon by itself is hard. Nylon with a PVA support is super hard because they won't stick together. And it turns out that there is a particular PVA that's meant to be used with nylon, which I now have. And the one I started with apparently wasn't. And so even though they're both PVA, there's some difference in the formula that the other one is supposed to work. So, but I still haven't perfected it. But yeah, nylon's super hard. It tends to be really gooey and stringy and yeah.
Are you having any, do you have any sort of like an enclosure?
Yeah, actually I do now. So I do have a big, a great big enclosure for this.
Can you print with the soluble support?
Yeah, that's what I'm talking about. I think it's PVA
Yeah.
I have water dissolvable supports. And the problem I'm having is getting, well, that stuff also is tricky to print just right. But the real problem is that the nylon and the PVA don't really want to stick together. And sometimes that's okay, but generally speaking, it just everything falls apart as you're printing it. So if I ever perfect that, then I'll have some really amazing parts. I sometimes have got the nylon to print really nicely, at least for part of the print, and it really is amazing. You know, and it's the CF nylon, so it's got chopped carbon cut fiber in it, so it's super, super strong. So
are you drying it before you're printing it?
Yeah, I have there was a Kickstarter for, I forget what it's called. There's a Kickstarter for a box that has, you put dual spools in it and it runs a heater with a temperature gauge and humidity gauge, and you just run it in that for 4 to 8 hours beforehand. So it helps. But yeah, it's tricky. And I think that's about everything that I have, which is good because my battery's going to die.
Very, very good. Thank you very much. I have to go, but it's very, very good. Thank you very much.
You're welcome. You're welcome. Any questions? Any other questions? You know, the thing about so the nice thing with Fusion 360 is that it is you can get it's free for personal use, free for educational use, and they also have had a startup license that you can get that's also free. And even if you have to pay for it, I think it's maybe $100 a month, something like that. So it's, you know, not a horrible commitment. I think I was last, but is there anybody else that had anything or wanted to present or anything?
When you were talking about that subscription, you're talking about Fusion 360?
Yeah, if you just walked up and paid for Fusion 360, at one point it was $100 a month. I'm not quite sure what the current price is.
It looks like they're moving to an online model with their offering to the educational community now.
Yeah, so I have a friend who has kids doing CAD and 3D printing in school, and their school has locked down their computers, even their Chromebooks, to the point where they can't use Fusion 360 because basically almost every time you started it, it wants to do an update. And now there's as we pointed out the other day, there's a fully web browser version. She says even that doesn't work. I'm not quite sure how they managed to lock things down so much that a normal browser app doesn't even work. But so yeah, so it's you know, that's sad. So hopefully that'll all get resolved. But you know, but it works for me, so that's pretty good. Anything else? Do we have anything else that we missed on the agenda?
So if somebody wants to see a FreeCAD, I have one open here. Nothing special.
I'm sorry, say that again.
If somebody wants to see a FreeCAD.
Oh yes, please. Yeah, that's the one. Yeah, absolutely. Oh no, that's fine. Sure. Can we here, let me stop sharing. Yeah, we're pretty late here, but please go ahead and show us.
So that's just a little thing I built last, because that's actually a dummy AA battery where I needed basically a more sustainable power supply instead of replacing batteries all the time. So that is a battery dummy with just some holes for some brass inserts and the hole for some cables coming out. So yeah, that just move that aside a little bit. That's it. So that is basically the thing I had in the middle and cut away from inside. So put that back in and not show it. And so now my battery is hollow again. And the same thing is basically here on a Prusa slicer. And not that big. Come back.
It's a big AA.
Come back. Really big now. Okay. And let's see inside. I actually wanted to show the little sharing it makes the zoom slow, and so there's no support needed for even for that hole. That's a 5mm hole, I believe. And so yeah, you can look at every layer, stuff like that. And then you can go to the printer. That's a Prusa printer connected to a Raspberry Pi with a Pi camera and Octoprint basically running. So right now nothing is printing there, but yeah, everything is here.
Yeah, very nice. Yeah, I use Octoprint. It works pretty well. There's a new there's a whole new system, but we don't have time to get into that.
Yeah.
So my son uses a different way a controller basically for the printer that externalizes most of the smarts of it to a separate module. So fantastic. Thank you very much. I think that gets us our whole set. Yep. Excellent. Back to you, Camp.
Okay, thank you very much. This concludes our 3D printing roundtable. Anything left before we adjourn this meeting?
Yes, I believe in chat, there was somebody that wanted to show off a project that they're working on.
Chi, are you out there?
Let me
Nolan?
scroll up.
Nolan?
Nanso, are you there? Do you still want to share your project?
I think Natso may have left the building. All right. Well, thank you very much. I'd like to thank Kevin Chow, Al Margolis, Scott Monahan, Maureen Davis, Damaris Davis, Dee, and our own Stephen Williams, our program chair, for organizing this 3D printer roundtable. Thank you very much. Big round of applause.
Thanks, everybody. Have a good night.
And
thank you.
The next meeting is going to be August 3rd, our business meeting. Everybody's on the mailing list. Yes, that's where you get all the information. And I motion this meeting be adjourned. Do I have a second?
Second.
All who agree, say aye. Aye.
Aye.
Those who oppose.